This video explains problems in probability and coordinate geometry which are asked in the GRE quantitative section. We're coming to the first problem. After 6 throws of a red die, so we throw a red die 6 times, the face that shows is marked blue. What is the probability that after 6 throws all the faces will be marked blue? So let's understand the problem. We want each of the faces to show once in the 6 throws, so that by the end of 6 throws, all the faces will be marked blue. In the first throw, any of the 6 faces can occur in one way. In the second throw, we don't want the first face to occur, so the remaining 5 faces can occur in 5 by 6 ways. In the third throw, the remaining 4 faces can occur in 4 by 6 ways, and so on. Ultimately, probability that all the 6 faces occur will be 1 into 5 by 6 into 4 by 6 into 3 by 6 into 2 by 6 into 1 by 6, which would give you 5 by 324. This is a basic theorem on probability which states that if A and B are independent events, then probability of A union B equal to probability of A plus probability of B. A and B are said to be independent events if the occurrence of one event does not depend on the other. Coming to the next problem, if a coin is tossed twice, what is the probability that it will land either heads both times or tails both times? Let A be the event of getting 2 heads. So probability of getting a head is half. So probability of getting 2 heads will be half plus half, which is 1 by 4. B is the event of getting 2 tails. So probability of getting B will be again half into half, which is 1 by 4. Now we are given that what is the probability that it will land either heads both times or tails both times. Whenever we have or, we use union. So we need to calculate probability of A union B. Since both A and B are independent, this is equal to probability of A plus probability of B. That is 1 by 4 plus 1 by 4, which is half. Coming to the next problem, x is a discrete random variable on the set of positive integers such that for each positive integer n, probability that x equal to n is 1 by 2 raised to n. If y is a random variable with the same probability distribution and x and y are independent, what is the probability that the value of at least one of the variables x and y is greater than 3? We need to find probability that at least one of x and y is greater than b. Before that, we use a basic law of probability which says that probability of A is 1 minus probability of A complement. So probability of A union B is 1 minus probability of A union B complement. Again, this is De Morgan's law that A union B complement is A complement intersection B complement. So this is 1 minus probability of A complement intersection B complement. Now let A be the event that probability of x greater than 3 and B be the event that probability of y greater than 3, because we need to find probability that at least one of A and B holds. Probability of A complement will be probability that x less than or equal to 3. That is probability that x equal to 1 or 2 or 3. We don't take probability of x equal to 0 because n is a positive integer. Probability that x equal to 1 will be half. Probability that x equal to 2 will be 1 by 2 squared, which is 1 by 4. Probability that x equal to 3 is 1 by 2 cubed, which is 1 by 8. So the answer of probability of A complement would be 7 by 8. Again, since y has the same probability distribution, probability of B complement, which is probability of y less than or equal to 3, would be 7 by 8. Since A complement and B complement are independent, it is given to you that x and y are independent. So A complement and B complement are independent. So probability of A complement intersection B complement is 49 by 64. We again make use of the fact that if A and B are independent, probability of A intersection B will be probability of A into probability of B. So probability of A complement intersection B complement would be probability of A complement into probability of B complement. That is 7 by 8 into 7 by 8, which is 49 by 64. We need to find probability of A union B. That would be 1 minus 49 by 64, which is 15 by 64. So your answer is 15 by 64. Coming to a problem on coordinate geometry, which of the following functions g does the graph of g intersect the graph of f? For which of these functions does the graph of g intersect the graph of f? Fx is mod 2x plus 4. So this is the graph of f and it has a y-intercept of 4. For the graph of g to intersect the graph of f, the slope of g should be greater than the slope of f. The slope of f here is 2. Slope is the coefficient of x. And the y-intercept of g should be lesser than the y-intercept of f. Here the y-intercept of f is 4. So we need g to be having slope greater than 2. For A, g has slope 1. For B, g has slope 1. For C, g has slope 2. D, g has slope 2. E, g has slope 3. And the y-intercept would be put x equal to 0. That is, so y is 2 by 3. So the y-intercept of g is 2 by 3. So for E, the graph of g would intersect the graph of f.